Okay, sorry, I made a mistake. I want to do minus 2x because it's more fun. Okay, so what am I going to do? What am I looking for? I want to find this power series here, Cn x minus a to the n, n starts at 0 in this case. And Cn is given by this formula, f to the n, with a plugged in, and don't forget to divide by n factorial. So that's what I want. I want this. And then Cn is given by this. Okie dokie. But in our case, we have a is 0, right? So this is actually just summation from 0 Cn xn. Because a equals 0 here because we're told Maclaurin. Okay, so you see how Cn involves an nth derivative. So we're just going to start making derivatives and then see if there's a pattern. So let's move this down actually, or let's move it over. So f of x is, that's f, we could write that as f to the 0, the 0th derivative, so e to the minus 2x. The first derivative is negative 2 times e to the minus 2x. Then the second derivative is minus 2 squared e to the minus 2x. The third derivative is minus 2 cubed e to the minus 2x. So what I do here is oops, what happened? Did I stop the video? No, I did not. Okay, what do I do here is I want to see the pattern. So if this is n, where is the n? Where are the n's appearing here? Well, just there, right? Okay, so I conclude from this the nth derivative of x is going to be negative 2 to the power of n e to the minus 2x. So we're saying therefore. So what I did is I took 3 derivatives and I was convinced that I had found the pattern. So I jumped right to the nth derivative. So I'll simplify a little bit here. And a little side calculation here, minus 2 to the n is minus 1 dot 2 to the power of n, which equals minus 1 to the n 2 to the n. Now I'm almost done here, right? Cn is nth derivative with a plugged in, all divided by n factorial. So memorized formula. So a is 0 in this case, right? So I'm just using my expression up here. And e to the 0 is just 1. So the Maclaurin series equals, as we said above, starting at 0, Cn xn, which is starting at 0. You can see I haven't really mentioned this, but I'm just using a short form here. What I mean is n equals 0 to infinity. You can abbreviate that like so if you want. And there we have it. Why don't I double check my answer before I move on? Yeah, good stuff. So there's my Maclaurin series. What is the radius of convergence? Well, how long is this video? Let's pause. You know what? I can finish in this video. All right, so I do ratio test. Where this is my AN. AN plus 1 all over AN in absolute value is going to be skipping some steps here. Oops. Show my plus 1 here. Plus 1. Okay, I dropped the alternating factor because of the absolute value. So this is AN plus 1, and this is 1 over AN. So moving on, what survives? We get 2 over n plus 1 times the absolute value of x. And then we do a limit as n goes to infinity. And we get 0, which is less than 1. And what we notice here is that this does not matter what the x value is. So it doesn't depend on x. Okay, this limit here ends up being 0 for any x value. So what does that mean? That means that all real values of x are fine. So my interval of convergence is minus infinity to infinity, and the radius is infinite.